Hello, in today's video we're going to be discussing solving trig equations. So here are some of our learning objectives. We're going to solve trig equations in sine and cosine. We're going to solve equations in single trig functions using a calculator, using quadratic form, and using identities. So essentially what we are going to be doing is taking an equation such as sine of theta equals 1/2, and we are going to be solving for our angle theta. So our first example, I would like to find the theta value that gives us a sine of 1/2 on the interval 0 to 2 pi. So what that means is we're going to be looking at the entire unit circle to find where our sine is equal to 1/2. Now hopefully you remember that when we are generally solving inverse sine functions, we are restricted to the domain of pi over 2 to negative pi over 2. But in this case, we are specifically directed to look at the interval from 0 to 2 pi. So on the interval from 0 to 2 pi, I'm looking for sine or a y value of 1/2, and I see that occurs at pi over 6 or 30 degrees. Then looking around at my y values, I see that it also occurs at 5 pi over 6, which is 150 degrees. Then continuing around my unit circle, I do see a y value of 1/2, but it is negative in the third quadrant, and I'm looking for positive 1/2, and same thing in the fourth quadrant. So on the interval from 0 to 2 pi, I see two places where my sine value is 1/2, and that is where theta is equal to 5 pi over 6, or theta is equal to pi over 6. In our next example, what we're looking at is finding all possible solutions for the equation sine of theta equals 1/2. So what I'm looking for is on any interval, what possible angles or theta measures would give us a sine of 1/2. So if I see my first sine value at pi over 6, what I can do is rotate pi over 6 radians, and that would land me at a sine value of 1/2. Or I could make a full 2 pi rotation and then land at my pi over 6. Or, as we've talked about before, I can make 2 rotations around my unit circle and then end at pi over 6. I can make as many rotations as I would like around my unit circle as long as I end at pi over 6. So my theta could be pi over 6, or we can add any multiple of 2 pi to that pi over 6. So I'm going to add on 2 pi multiplied by some constant k, where k is an integer. So we are saying that I can add on no 2 pi's, and that means I just go straight to pi over 6. I can add on 1 2 pi, so I make 1 full rotation, and then I end up at pi over 6, or 2 of those 2 pi's, or 3, meaning 3 rotations, and so on. For my other option, I had an angle of 5 pi over 6, so I can go around to 5 pi over 6 directly, so theta could equal 5 pi over 6, or we can rotate around our unit circle any number of rotations. So I can rotate 1 full time and then end at my 5 pi over 6. I can make 2 rotations, 3 rotations, or so on. So I can add on as many rotations as I'd like, so as many 2 pi's as I'd like. So I write plus 2 pi multiplied by some constant k, where k is an element of my integers. Go ahead and take a moment to pause the video and try example 641 and 642 on your own. So we should be looking for theta values of pi over 3 and of 5 pi over 3. Those are my solutions in my 0 to 2 pi interval, which means all possible solutions would be pi over 3 plus 2 pi k. Or theta could equal 5 pi over 3 plus any number of rotations around the unit circle, and those would be the values of theta that we can use to get a cosine of 1/2. In my next example, example 643, we've got a slightly more advanced trig equation that we're working with. Well, what I want to do is I want to narrow this down into, if possible, sine of theta equals some ratio. So what I'm going to do is I'm going to manipulate my equation so that I have sine of theta equals some ratio. And then I can hopefully use the unit circle to identify what that theta value is. So just like in a normal equation, I'm going to go ahead and combine my like terms. So I'll start by subtracting 2, just so I keep my numbers positive. Then I've got 3 sine of theta plus 1 is equal to 5 sine of theta. And if you are comfortable with this, then we can say, okay, well, I want to isolate my sine theta, so I need to make sure that I combine those like terms. I have 3 sine thetas on the left, so I'm going to take away all 3 of those sine thetas from the left side and the right side. That leaves me with 1 equals, and then on the right, now I have 2 of those sine thetas. If you're uncomfortable with that, basically what I did is I said, I've got 3 of something plus 1, and that's equal to 5 of that same thing. So I took those 3 somethings from the left and from the right, and I'm left with 1 is equal to 2 times something. Here that something is just sine of theta. So now I'm trying to isolate sine of theta because remember my goal is to see sine of theta equaling some ratio. So in order to isolate, I then divide by 2 on both sides to get rid of that coefficient, just like I would divide by 2 if solving for x in the second equation. So on the left, I've got 1/2 equals on the right sine of theta. So sine of theta is equal to 1/2. And they would like us to solve this equation on the interval from 0 to 2 pi. So just like in our last example, I'm going to find the value of theta on the interval 0 to 2 pi that gives us a sine of 1/2. So I see that occurring at pi over 6. I've got a sine value of 1/2, and I see it occurring at 5 pi over 6. Since we're restricted to the 0 to 2 pi interval, those are the only 2 answers that I'm looking for. So theta equals pi over 6 or 5 pi over 6. So we simplified our equation as far as we could to solve for our sine of theta. And then from there, we solve for theta by using our unit circle. Okay, go ahead and take a moment to pause the video and try example 643 on your own. So again, in this example, what we are looking for is sine of something is equal to my ratio. I'm going to go ahead and call this angle theta for now. So this is step 1. Isolate your sine. So to isolate sine, I start by adding 7 to both sides of my equation. So I have -1 is equal to 2 times the sine of 3x plus 5. And then I divide by 2. I'm not worried about what is inside for my theta right now. I'm only trying to isolate my sine. So I've got -1/2 is equal to sine of 3x plus 5. So now from here, I need to find where on my unit circle sine is equal to -1/2. So I'm going to go ahead and let this 3x plus 5 be theta, just for now. So -1/2 is equal to sine of theta. And I just let theta be equal to my 3x plus 5. So now I can figure out what that angle needs to be. Then once I find that theta, I can go back and figure out what x value I need to have in order to get that theta. So on my unit circle, we are looking from the interval of 0 to 2 pi. I want y values of -1/2. So that would be at 7 pi over 6 and at 11 pi over 6. So the two theta values that I want are 7 pi over 6 and 11 pi over 6. So what we have found is that sine of 7 pi over 6 is equal to negative 1/2. Similarly with 11 pi over 6, sine of 11 pi over 6 is equal to negative 1/2. But they haven't asked us to find theta. There was no theta even in the question. What they asked us to find was x. So if this is true, I then go back up to the equation that I used to substitute. So I'm going to go back up here and say that that 7 pi over 6 is my 3x plus 5. I need to find what x is. So now I know that all of this inside those parentheses is 7 pi over 6, so I'm going to write an equation to solve for x. So I know that 7 pi over 6 is equal to 3x plus 5. So I subtract my 5 from the left and from the right. 7 pi over 6 minus 5 is equal to 3x, and then to get a common denominator, I'll multiply top and bottom by 6. So 7 pi minus 30 all over 6 is equal to 3x. And then I divide everything by 3, or multiply by 1/3, since we're dealing with a pretty ugly fraction here. Multiply by 1/3. And I've got 7 pi minus 30 over 18 is equal to x. So that would be the first solution to my equation. So I took this first equation and solved by substituting my 7 pi over 6 in for theta to find my value of x. I'm going to repeat that process by taking my 11 pi over 6 and allowing that to equal 3x plus 5. So my second equation, I know that that angle inside could be 11 pi over 6, and that could equal to 3x plus 5. Subtracting 5 just like before, 11 pi over 6 minus 5 equals 3x, and then I'll add by getting a common denominator. 11 pi minus 30 all over 6 is equal to 3x. And then I'll multiply by 1/3 to reduce those 3's all the way. And I end up with 11 pi minus 30 all over 18 is equal to x. So I've got two solutions for x on my interval from 0 to 2 pi. I'm going to take you through one more example and then we'll go ahead and conclude the video. So in example 644, we have the trig function of cosecant in our equation. So what I'm going to do is I am going to rewrite this using the sine function, since I know that cosecant is actually 1 over the sine of theta. So I've got 1 over the sine of theta is equal to -2, and I want to know what is the exact solution on the interval of 0 to 4 pi. So now we're talking about 2 rotations on the unit circle. So to solve for sine of theta, I'm going to go ahead and multiply both sides by sine of theta. That gives me a 1 equals to -2 times the sine of theta. And then just like in our previous examples, I divide by -2's on both sides, and I get -1/2 is equal to sine of theta. So now on 2 rotations on the unit circle, I want to know what value of theta gives me a sine value of -1/2. So going back to my unit circle, I see that I've got a sine value of -1/2 at 7 pi over 6 and at 11 pi over 6. So theta could be 7 pi over 6, or it could be 11 pi over 6. Now the interval that we're looking at is from 0 to 4 pi, so I only looked at one rotation around the unit circle, or 0 to 2 pi. So I can make another rotation around the unit circle, which would just add 2 pi to each of my theta values. So I also have 7 pi over 6 plus 2 pi, and 11 pi over 6 plus 2 pi. That concludes our video today. Thanks so much for watching.